You're watching your baby kick their legs wildly, and the movement looks completely random, chaotic, like a tiny person who hasn't figured out their body exists yet. But researchers who've spent decades studying infant motor control just discovered something that changes everything we thought we knew about what's actually happening in those moments. Those kicks aren't random at all. Most parents assume babies flail around because their nervous system is underdeveloped, firing signals without purpose or direction. That explanation sounds scientific enough to be reassuring. It's also completely backward. When a 3-month-old kicks their legs in that rapid-fire pattern that looks like they're trying to run in mid-air, their brain is performing a level of motor planning that most adults couldn't consciously replicate if they tried. Here's what nobody tells you. A researcher named Galloway at the University of Delaware ran an experiment that overturned 50 years of assumptions about infant development. He placed toys in front of babies' feet, not their hands, and watched what happened. The babies reached out with their legs and made contact, deliberately, accurately. And here's the part that stopped the entire field cold. These infants were contacting objects with their feet, up to a month before they could do the same thing with their hands. That violates everything developmental psychology assumed about how humans gain motor control. The cephalocaudal rule, the idea that development moves from head to toe, top to bottom, has been medical consensus since the 1940s. Babies should master their hands first, then their legs. But Galloway's data showed the opposite actually happening in real time. Why would legs develop control before arms? The answer rewrites what kicking actually means. Your baby's arms can move in virtually unlimited directions and angles. The range of motion is enormous, which means repeating the exact same arm movement twice is neurologically complex. But legs? Their movement is restricted by hip socket design, by the weight of the limbs, by basic biomechanics. That restriction becomes an advantage. When a baby kicks and something interesting happens, maybe their foot hits a mobile, maybe they feel the texture of a blanket. Their brain can reproduce that exact movement far more easily than any arm motion. Each kick is a test, a neurological experiment running in real time. The baby's brain is asking, what happens when I do this? And then it runs the experiment again and again. What looks like wild, purposeless kicking is actually the most sophisticated form of learning available to a human being without language. But there's something happening during those kicks that goes deeper than motor learning, and it explains why the kicking intensifies at specific times. You've probably noticed your baby kicks hardest when they're excited, when they see your face, when the bathwater starts running, when something captures their attention. That's not coincidental. Babies can't talk. They can't point with accuracy. They can't gesture in ways adults understand. Movement is their only fluent language. When a 4-month-old sees something amazing, their entire body responds. Heart rate increases, breathing accelerates, and their legs start pumping. Researchers call it motor overflow. The brain's excitement literally spills into the motor system. That leg pumping is your baby shouting without vocal cords. It's them saying, "This matters. I'm experiencing something significant right now." And the wildness of the movement correlates directly to the intensity of their emotional state. Faster kicks mean higher arousal. Stronger kicks mean more excitement. You're watching emotional regulation happen through pure physical expression. Now, I need to tell you about what happens at night, because the nighttime kicking reveals something most parents completely misinterpret. You put your baby down. They seem settled. Then 30 minutes later, you hear the rhythmic thump of legs hitting the mattress. Over and over, some parents panic, assuming discomfort or pain, but sleep researchers studying infant brain activity found something unexpected. Newborns spend roughly 50% of their sleep in active sleep, the infant equivalent of REM. That's double what adults experience. During active sleep, the brain is running at extraordinary intensity, processing everything the baby experienced while awake. And unlike adult REM sleep, where the body enters near complete paralysis, infant nervous systems don't have that shutdown mechanism fully developed yet. The result? Their brains are processing motor movements, building neural pathways, and their bodies are acting it out. Those nighttime kicks aren't disturbing their sleep. They are sleep. Or more accurately, they're the visible evidence of learning happening at the neurological level. The baby's brain is literally practicing walking before the body can stand. But here's where it gets genuinely strange, and where most pediatricians won't have an answer for you. Some babies develop a specific pattern around 3 to 4 months old. Rhythmic leg kicking right before sleep. The same motion, the same intensity, every single night. Parents call it whale kicking. Researchers call it self-soothing motor behavior. The proprioceptive input, the sensory feedback from the muscles and joints moving, creates a calming effect. It's the infant equivalent of rocking yourself to sleep. The repetitive motion helps regulate their nervous system, helps them transition from the chaos of being awake into the neurological state required for sleep. They're not fighting rest, they're using movement to find it. And then there's the type of kicking nobody wants to talk about, but every parent has seen. The distressed kicking. When the legs pull up toward the belly, when the movement looks jerky, uncomfortable, accompanied by crying or clear agitation. That's a completely different neurological signal, and recognizing the distinction matters more than most parents realize. When babies pull their legs toward their chest, especially during crying episodes, their digestive system is communicating through the only channel available. A newborn's gut is still learning how to process food efficiently. Gas bubbles form. The intestinal walls contract, pressure builds, and the baby's nervous system responds by triggering a flexion reflex. Pulling the knees up increases intra-abdominal pressure, which can help move trapped gas through the system. It's not a conscious decision. It's the autonomic nervous system attempting to solve a physical problem through movement. If you see this pattern, legs drawn up, visible discomfort, crying that intensifies with the movement, you're watching pain communication. The response isn't to stop the movement is the attempt. TED solution. Your job is to address what's causing the gas in the first place. But there's something else happening with leg kicking that almost nobody recognizes, and it involves a phenomenon that overturns everything we thought we knew about infant motor control. For decades, developmental psychology operated on a principle called the cephalocaudal rule. Development proceeds from head to toe. Babies gain control of their head first, then arms, then trunk, then finally legs. It's in every textbook. Every pediatrician learns it. And recent research has proven it's incomplete. Dr. Galloway at Temple University ran an experiment that changed the field. He placed toys within reach of infants, some near their hands, some near their feet. What he observed contradicted 60 years of established science. Babies contacted toys with their feet, up to a month before they could do the same with their hands. They weren't flailing randomly, they were reaching with their legs, deliberately, accurately, before their arms had developed the same level of control. Why? The answer reshapes how we understand early motor learning. Arms have an enormous range of motion. Shoulders rotate, elbows bend, wrists twist. That freedom creates complexity. Legs, by comparison, have restricted movement patterns. Hips and knees work within tighter constraints, which means when a baby kicks and successfully contacts something, repeating that exact movement is easier. The simpler biomechanics allow faster learning. Your baby isn't just randomly kicking. At 2 months old, they're already running experiments, testing whether their foot can reach that object, adjusting the trajectory, building an internal model of how their body moves through space. This is spatial awareness under construction. Every kick that connects with the side of the crib, every foot that touches a dangling toy, every leg that brushes against your hand, that's data. The baby's brain is mapping the boundaries of their body and the space it occupies. Neuroscientists call this proprioceptive development. You call it your baby being wiggly. But what's actually happening is they're answering the most fundamental question a consciousness can ask. Where do I end and the world begin? Now we need to talk about what happens when the kicking changes, because developmental pediatricians use leg movement patterns as diagnostic indicators that most parents don't know exist. Asymmetric kicking, where one leg moves significantly more than the other, can signal neurological issues if it persists beyond the newborn period. By 3 months, kicking should be relatively symmetrical. If it's not, if one leg consistently seems weaker or less active, that's worth a conversation with your doctor. Similarly, a sudden decrease in kicking activity, especially if accompanied by other changes in behavior or feeding, can indicate something requiring medical attention. But there's a more subtle pattern that reveals something profound about cognitive development. Around 4 months, you might notice your baby staring at their own legs while kicking, watching their feet move, tracking the motion with intense focus. This isn't vanity. This is the birth of body awareness. They're making the connection between the intention to move and the visual feedback of movement happening. That moment, when a baby realizes those feet belong to them, that they're controlling the motion they're observing, that's a milestone as significant as recognizing faces. It's the neurological foundation of the self. Researchers studying infant cognition have found that babies who spend more time observing their own movements during this window show faster development in motor planning skills later. The act of watching themselves kick literally accelerates the brain's ability to predict and control future movements. Your baby isn't being narcissistic. They're running a feedback loop that's constructing the neural architecture they'll use to walk, run, and dance. There's one final piece that brings all of this together, and it explains why some babies are aggressive kickers while others are gentler. Temperament research has identified consistent individual differences in motor activity levels that appear in the first weeks of life and remain stable into childhood. High reactive infants, babies with more sensitive nervous systems, tend to show more vigorous limb movements in response to stimulation. Low reactive infants show calmer, less intense motor responses. Neither is better. Both are normal variations in how nervous systems process arousal. What matters is recognizing that your baby's kicking style is telling you something about how they experience the world. The baby whose legs pump wildly at every new sight is showing you they feel things intensely. The baby with smoother, more controlled movements might be processing stimulation differently, not less engaged, just regulated differently. Understanding this helps you calibrate your responses. The vigorous kicker might need help calming their system. The gentle mover might need more stimulation to stay engaged. So the next time you watch your baby's legs pumping in the air, recognize what you're actually seeing. Muscles being built for walking that won't happen for months. Emotions being expressed through the only fluent language available. A nervous system practicing movements while consciousness sleeps. Spatial boundaries being mapped through thousands of tiny experiments. A self being constructed, one kick at a time, in the most sophisticated developmental process biology has ever produced. That's not random movement. That's a human being learning how to exist in a body, and you're watching it happen in real time. If your baby has ever done this, kicked wildly at something invisible, practiced walking in their sleep, or stared at their own feet like they just discovered fire, drop a comment. Tell me what age, what pattern you noticed, because every one of those kicks is writing a story about who they're becoming. And if you want to understand why babies stare at you with that unblinking intensity that makes you feel slightly transparent, why their gaze locks onto your face and refuses to let go, that video explains the neuroscience behind what's actually happening when those eyes won't look away.